All right, let's talk about sets in Python. So a set is a collection of unordered, order doesn't matter, unique, only one of any given value in the collection, immutable values, so they can't change. So we see an example of a set here, defined with curly braces as a literal. Red, black, white, blue. We can define a set using this literal means, or we can also define one by using the set built-in. Now here's what you'll notice when we do this is that blue is in here twice or 3 times, but then when we make the set, blue only appears once. Now, it's worth noting that you can't use a literal to create an empty set because the empty set literal would be exactly the same as an empty dictionary, and that's what Python thinks it is. Reason being, the dictionary is really what people end up using more often. Now, there is a hack to get around that, which is you can make a literal with just an item in it that doesn't have a key and value pair. It's just one item, at which point Python will recognize it as a set, and then you can remove that item and it'll still know that the type is a set. You can even convert a set from a string, although I confess I'm not clear why you would do this. If you take this string and you make a set out of it, then you're going to get a set where each character is represented as an item in the set. Now, what would you use this set for, right? Well, there are a number of different situations where a set might be valuable. Imagine, for example, that you were implementing an elevator, and you want the elevator to visit every floor that's been requested. Suppose that you have a whole bunch of people standing on floor 3, and each of them has pressed the floor 3 elevator button. Now, if you put those items in a list, then when the elevator showed up, suppose you remove 3 one time from the list, but 3 might still be in there a whole bunch of times. You only want the elevator stopping once at each floor that's been requested. A set's valuable in that case because it's going to have each item in the collection once or 0 times. Another advantageous use of sets is if we have different collections of items and we want to be able to determine whether items are in both collections or in neither collection. So we can use them in situations where it would be valuable for us to be able to calculate something like a Venn diagram, the set of objects that isn't the same as some other set of objects, or the set of objects that can be included in 2 different circles. So how would we do that? We could do that with set theory operations. Sets are fundamentally mathematical in nature. So we can use operations based on set theory within a set. Let's talk a little bit about some of those operations. First one is a union. The union of 2 sets is going to be a set containing all of the elements that are in both sets. So if I got these sets up here, CEADB at YZXDB, that should include everything in both of these sets. We can do union with one set dot union another set in Python, or we can also do it with the union operator, which is a pipe. So now you see that we have all of the items from both of those sets represented here. Now, how about difference? Difference allows us to calculate a set consisting of the elements that are in one set but not another. So here's a fun language fact for you. In Ruby, you can subtract arrays by taking one array and removing another one. This is going to give you an array of 2 because that's the item that's in this array but not in this one. Python does not support this because order matters and because Python, as it is written, the Python interpreter doesn't consider subtraction an operation that you can do when the order of the elements might not be the same in the 2 arrays. That order is somehow part of the way that we are interpreting each item in our list. So if you want to do this operation the way that you might do it in Ruby, you have to convert the list to sets first, so that that same operation in Python would look something like this. We have an array, and we make a list containing the set of 1, 2, 3 minus the set of 1 and 3. So let's look at the difference operation on the set here. When we do A minus B, we could see that what we're going to end up getting is all of these minus any letters that also appear in here. All of these minus any letters that might appear in here. And we see that here, the D and the B are missing. We can do the same thing the other direction. Here we use a minus sign, and here we use the difference function. But it's the same result, which is that the D and the B, which are shared between the two sets, are subtracted from each one when we subtract one set from the other. Now let's talk about the intersection. The intersection of two sets is a set that consists of all of the elements that are in both of those sets. So, not either of those sets, but rather both of them. So, what do you expect A intersection B is going to be? It'll be DB, because those are the two elements that are in both of the sets. There are a number of other methods that we can call on sets as well. We can change a set, but we just can't change the elements in the set itself need to be immutable, but the set is mutable. So suppose that we have this letter set. We can add the letter D to our set. We can update the set to include any items in a list that it doesn't already include, any items in a set rather that it doesn't already include. We could delete an item from a set with the remove function. And we can also iterate through a set with a for loop the same way that we would do with any of the other collections that we have seen so far. There are a number of other methods that we can use on sets. And once again, you could visit the documentation to find these. All right. So let's talk a little more about the immutable constraints on sets. I mentioned that a set is mutable, but it can only contain immutable object types. Now, hashable object types and immutable object types in Python. Why do these matter? We saw these before in our dictionary video, where we discussed the fact that if you have a key in a dictionary, the type of that key has to be hashable. That is, the key has to be of some type that cannot be changed. Why do you think that is? Well, if we're using an object as a key pointing to another object, and that key changes, then we're going to lose access to the object that it was originally pointing to, unless we do some relatively complicated and memory-intensive operations in the interpreter. So, we use specifically immutable and hashable object types. Now, that doesn't mean that immutable and hashable mean the same thing. Immutable means it can't be changed, and hashable means that we can come up with a unique hash representation of that type. You don't have to worry too much right now about what that means, but it's going to end up producing much faster lookups for us when we do the actual implementation of looking up items. Okay. So it's also worth noting that lists and dictionaries, because they are mutable, cannot be embedded in sets. But tuples can be embedded in sets. Why is that? Because tuples are immutable. So we see here one more set. We're going to add some items to it. Oh, we're not. And why is that? Because we tried to add a list. And a list is an unhashable type. We see the same thing when we try to add a dictionary to a set. But if we try, if we try to add a tuple, we see that it adds just fine. So sets themselves are mutable, as we've discussed. So do you think that you can put a set in another set? Turns out you can't. A set's not hashable, so a set cannot be an element of a set. Dictionaries can be values in dictionaries, and lists can be values in lists, but sets cannot be values in sets. Now, if you need to include a set in another set, you do have an option, which is to use the built-in frozen set function. What this does is it gives you a set that is immutable, cannot be changed, and you can embed that in other sets. Now, other than that one change, frozen sets work just like sets. So you can see that this built-in here converts our set to a frozen set. And then we can add that frozen set perfectly fine to our original set. But when we try to change our frozen set, it tells us that the frozen set has no attribute append because you cannot change it.